All right, so this is a 20-foot Lancer Craft Elite. They wanted to build a electric prototype, so they sent the hull over here, and we're outfitting it with an electric drivetrain. It's about 250 kilowatts. We're gonna put 80 kilowatt hours of solid state batteries into it, making a 400 volt system. Expected speed out of this boat should be 30 to 35 knots. With the system that's going into it as a prototype, it's got kind of a limited range, probably about a half an hour at full throttle. It can carry a handful of people, driver and 3 or 4 passengers. Should be really comfortable. Probably ideal for like lakes or rivers, smaller bodies of water, mostly because of the range. I'm sure that they'll option this with a longer range package. It wouldn't be very hard to fit more batteries on this boat. Just in the form factor that we have available to us off the shelf, 80 kilowatt hours is kind of the sweet spot for packaging. Most of what I'm doing is the propulsion system. I'll button up the 12 volt system as well. There's a couple of things that I've noticed that need changing. It's just a very classic looking, you know, vintage Chris Crafty hull. The seats are very comfortable. They're out of the seat bottoms are out of the boat right now, but it's a very comfortable boat interior-wise for being like a day cruiser. And then the engine compartment is where all of my magic is happening. We're gonna fit a motor mount bracket set up here. The motor will sit there and mount up to prop shaft. I've got some battery trays that are coming in hopefully this afternoon. We'll be fitting 4 batteries per side for the solid state 8D sized batteries. They're 10 kilowatt hours each. So that gives us the 80 kilowatt hours total. All of our controls and high voltage equipment go towards the front end of the engine compartment. This motor is water cooled, so there will be water coming in, going through the motor and going out. Normally what I would do is a closed loop system, so I would have a heat exchanger, and that's something because I'm in most of the boats that I do are in a saltwater environment, so I don't want salt water going through one of the most expensive components on board, which is the motor. The batteries do not need any liquid cooling. We're well within their ratings for amperage draw at full throttle. Because this is a prototype, we don't have some of the systems that I would normally put in, so normally I would put in a DC to DC converter to take 400 volts and drop it down to 12 volts for the 12 volt house systems. This boat we're going to just install so that it's ready for the boat show that it's going to be debuted at. We're going to just install a 12 volt battery, and then it will probably come back to the shop and we'll do a bunch of the other work to get it cleaned up a little bit more. It's going to be at the Boston Boat Show at the beginning of January. I think that's the 7th to the 11th. So we won't have dipped this boat in the water before the show, but after we're going to do some sea trialing. All of the systems will function. We will have some systems that need to be buttoned up after the show, but that's kind of normal, especially on a prototype boat. This is probably going to be an evolving project. So the story there is I was going up to Solid State to pick up some batteries that I had ordered, and Tom up at Solid State asked me if I had a busy month for December, and I said no, and he said, "You want to do this boat?" And I said sure. So kind of a cool connection with Solid State and me. I've almost exclusively been doing solid state batteries, so having the opportunity to work on a boat like this is a great opportunity for me and my business, and helps to bolster my relationship with Solid State, and maybe I can get into some OEM installations. That would be pretty sweet. A lot of it has to do with weight and power density and battery safety. So NMC, nickel manganese cobalt batteries, are a bit more volatile than lithium iron phosphate. The solid state batteries are about 3 times the power density for the same amount of weight as a lithium iron phosphate battery. So we would be able to put in about half of the capacity that we can put in with the solid state if we went with a lithium iron phosphate battery, and they would take up more room and be heavier. You know, this is a go fast boat, so weight is definitely a consideration. You know, if this was a big heavy trawler, I would still go solid state, but space would be the consideration over weight. The total battery bank in this boat is going to be about 640 pounds, and then the motor is about 200 pounds. We're still within a reasonable amount of weight to what a full tank of fuel. And I believe these engines that come in this boat are a 5.7 Chevy V8. So those are, you know, they're not light motors. We're probably pretty close to equal in weight at this point. And the weight is more consistent. In the future, if they wanted to do something with trim, we could put batteries in different places and the weight would stay consistent. The front edge of the battery tray is gonna go here, and it's gonna go about, I believe it's 43 inches that way. So we're gonna have two battery trays, one on either side, roughly here and here. We'll have the 12-volt battery probably tucked up right in here, right up against the forward bulkhead. So along with the batteries on the battery trays, each battery gets an isolation relay. When you power down the whole system, you can individually shut off each battery, so you're not working with 400 volts at every connection. You can isolate a battery and just take that 48-volt battery out. I'm sitting where the motor is going to be. We've got an inlet for cooling water here. It's going to come up, forward, through the motor, and then out through one of these three exit ports. Two of them are for bilge pumps, one is for motor cooling. If it comes in time, I'll probably mount the heat exchanger right here with a closed loop for the motor and then an open loop for hot water discharge. Not that this water gets very hot. We're looking at, you know, temperature ranges in the high 90s to low hundreds. We've got to be able to get heat out of this system. So this pad, roughly the size of the frame for the solid state batteries. We're going to have 4 8Ds right next to each other on each side, so they'll be mirror images. If we were going to use LFPs, I'd have to move this line forward and it would go all the way back to almost a transom for a little less power. We could probably move it up to where this 12-volt battery line is and have the same amount of power. But then we've also got other components that have to live in these spaces. We've got power coming in from shore power that needs breakers and switches. We've got 12-volt and the high voltage battery chargers. We've got the high voltage distribution box, a couple of other components that need to go into this space. So that's why I'm kind of cheating the batteries back a little bit. Well, on this boat, I mean, space saving is a big deal because, I mean, you can see how little space that I have to work with. And then also weight. This is a relatively lightweight boat. On a larger boat, like a sailboat or a trawler or something like that, cruising boat, weight isn't as much of an issue, but then you run into space issues because if you're on a cruising boat, you've got all your toys with you, you've got all your stuff with you. You know, people have a lot of stuff. Space is the issue when it comes to cruising boats. And solid state has more space-saving qualities, being more power dense than any of your other options.